I'm working in an interactive climate history project. The project depicts Earth's climate history in 5 panels going back in time to 550 million years ago. We're looking at the first panel that covers a period of time from the present on the left to 20,000 years ago on the right. There are 3 graphs that are important here. We have one for the temperature, one for sea level, and one for carbon dioxide in the atmosphere. Each of the 3 graph lines is accompanied by its own range. In this case, we have the temperature range, which is indicated by this chart here in this particular panel. The sea level is indicated by this chart here, and carbon dioxide by this chart here. I'll point out that the present Earth's temperature is represented by the 0 here, that would take us out along this black line you see scribbled here. Present sea level is indicated by the 0 on the chart here, and that runs out in kind of like this direction across the chart. Now I have a moving X in this project. That's this guy here. And if we move along the project, and I do that by playing it, we're using these little indicators. I'll use an indicator. You can see that the X changes position. We have a blue box here that indicates the time period that we're currently looking at on this chart. In this case, where the X is parked, starts us at 3,000 years ago, and the next X will take us to 4,000 years. So if I jump to the next X, there's our 4. So in this zone here, we're going between 3 to 4. You can see temperature is pretty flat and sea level is fairly flat, although trending down slightly. Again, the present is on the left, the past is on the right. Now I'm gonna jump us to the beginning of the next panel. This panel covers a period of time from 20,000 years ago on the left, to 1 million years ago on the right. Notice the peaks and valleys on the temperature graph here. These oscillations are basically called Milankovitch cycles, and they have to do with the Earth's climate being driven by changes in the Earth's orbit around the Sun, particularly its eccentricity or whether or not it's going around in a circle or in an ellipse, also the tilt of the Earth's axis, and the precession of the axis. These cycles are called Milankovitch cycles, and for the last million years, they have occurred approximately every 100,000 years. If you take a look at the sea level graph here, you'll see that it will generally follow the same cycles that the temperature curve follows. That also holds true for carbon dioxide, which is generally in agreement with the Milankovitch cycles that affect the Earth's temperature. We're gonna navigate back to the first panel. I want to point out that the period of time from here to here is referred to as an interglacial period. That means that the Earth has entered a warming period in those Milankovitch cycles, and the Earth has warmed up, as you can see here. And, of course, when it warms up, glaciers will melt and, of course, sea level will rise and hopefully eventually level out. And it levels out because at some point in time, the next cooling cycle will kick in. And once again, temperatures will drop and sea level will start to drop again. Going back to the panel. It starts at 20,000 years and goes through 1,000,000. I want to point out that if we look at the Milankovitch cycle that happens, and let's see. We'll move our X over to that. Okay. It looks like the peak happened at about 120,000 years ago. And I want to point out that if you look at the peak of the temperature curve, it's about 5 degrees Fahrenheit warmer than today's temperature. And, again, the 0 line here is today's temperature. The last time we went through a warm period in this cycle, temperature was much warmer than it is today. I'll also point out that at that same time, sea level was much higher than it is today. Again, current sea level is represented by this thin black line, and you can see this red notch here. And let me zoom in a little bit here. If you look closely, you can discern that sea level at this peak is about 8 meters, or 26 feet, higher than today's sea level. So what I'm saying is that 120,000 years ago, during the previous interglacial, the Earth's temperature was a lot warmer than today, and the Earth's sea level was a lot higher than today. And if you examine the sea level curve, you'll see that during this interglacial sea level was higher than today's average. So the fact that sea level is currently slowly rising should come as no surprise. I'll also point out that not only during the previous interglacial was Earth's temperature high, it was high during every one of the preceding 4 interglacials. Now one of the reasons that modern humans have a hard time understanding this concept is because we haven't been around that long. Modern humans have never lived through a complete Milankovitch cycle, particularly in the northern hemisphere, where lots of glaciers form, where the temperature went from warm interglacials to a very cold part of a glacial period, jumped up to a next interglacial, and so forth. Again, the previous interglacial was a lot warmer today, and it dropped down to where the temperature was running, maybe 8 degrees colder than today. Go back to the first panel. You can see that at the coldest, the temperature, which again was running about 8 degrees colder than today, took, 8,000 years or so, to get up to where it's close to today's temperature. And it stayed that way with some minor variations, all the way up to the present. And even in the present, we've experienced a slight warming. However, that slight warming is nothing unusual. If you go back 4,500 years, and take a look at the details in this chart, you'll see a lot of periods during this span of time where Earth's temperature was significantly above and then significantly lower than today's temperature. Let's take a quick look at that period of time in more detail. This chart plots volcanic and historical events over a period of time spanning from 2500 BC to 2040 AD, or a few years into the future from the present. The time scale is shown here on this horizontal axis, with this being 0 BC, and the temperature scale here shows the average Earth temperature. 57 degrees Fahrenheit being the average Earth temperature in the present. I'll point out that as you can see from excursions in temperature going from warmer to colder than present in the not too distant past, Earth's temperature has been several degrees warmer than the present. Also in the very recent past, during what's called the Little Ice Age, Earth's average temperature was almost 3 degrees colder than present. This chart is best viewed by pausing the video and looking at all the notations as they're scattered all over the chart. Note the many different volcanic eruptions that are noted, as well as the few significant historical events.